Welcome everyone to another video where we are going to solve problem number 2 of third chapter, which is equilibrium of a particle in the book of engineering mechanics, the statics part by R.C. Hibbeler. In this problem we are being asked to determine the magnitude of F1 and the angle which F1 is making with the positive x-axis theta. Before solving this problem, let me tell you that the audio track of this video is available in different languages. If you want to listen this video in any other language, then just go to setting button where you can change the audio track of your interest. So let's solve this problem. Since it's all about equilibrium, so in order to be in equilibrium, all the conditions should be satisfied. Means all the forces acting in x and y direction should be equal to 0. All the moments acting on the body should also be equal to 0. Since in this case, all the forces are passing through the point O, means there is no need to take the moment in this case. So we'll just use the first and second condition of equilibrium. The first condition of equilibrium is summation of all forces acting in x direction equal to 0, considering all the rightward forces as positive. So we will have the x component of F1 as F1 cos theta, the x component of F2 as F2 cos 20 degrees, the x component of 5 kilonewton would be 5 cos 30 degrees. The x component of 7 kilonewton would be 7 multiplied by base upon hypotenuse, means 4 over 5. Hence this F2 and F1, which is rightward, those should be positive. So F1 cos theta plus F2, which is given, its magnitude is given, so 6 cos 20 degrees minus 5 cos 30 degrees minus 7 multiplied by 4 over 5 equal to 0. So from here we will have F1 cos theta equal to, because all three will have some value because we can solve them, and when you solve it, it will have negative 4.29, and if you shift on the right hand side it will become positive, so 4.29. Now we cannot move further, both theta and F1 are required. So let's shift towards the second condition of equilibrium, which is summation of all forces acting in y direction equal to 0, considering all the upward forces as positive. F2 will have upward force of F2 sine 20 degrees. F1 will have downward y component, F1 sine theta. 5 kilonewton would have upward y component, and 7 kilonewton will have downward y component, having the magnitude of 7 by perpendicular over hypotenuse, because in this case we are using sine, so 3 over 5. So F1 sine theta should be negative since it's directed downward, but F2 sine 20 should be positive because it is directed upward. F2 6 sine 20 degrees. 5 sine 30 should also be positive since it's upward, and the y component of 7 should be negative since it's downward. So these three values can be solved further. So on solving, these values will result positive 0.352, and since this is negative, if we shift on the other side it will become positive, so positive sine theta, which should be equal to positive 0.352. Now we have these two equations. In these two equations, if I divide equation 2 by equation 1, which will result F1 sine theta divided by it's actually F1 cos theta, so 0.352 divided by 4.29, since F1 and F1 on both above and below will get cancelled, and you know that sine theta over cos theta is actually tan theta, so this tan theta would be equal to 0.082. If you calculate the tan inverse of this, you will result the angle as 4.69 degrees as the angle of F1 force, and if you put in any of these equations, you will result the value of F1. Let's say if I put in equation number 1, so on solving we are going to get the value of F1 as 4.31. So both the magnitude of F1 and its angle is now being calculated. That's what it was required in this question. So that's all from this video. I believe you have now learned how we can determine the magnitude and its direction of one force which was unknown, but that unknown force was actually making the body in equilibrium. For that, this is how the calculation should move forward. If you have any question, then please let me know through the comment section so that I can get back to you. That's all from this video. Thank you for watching this video. I hope to see you in next coming videos. Till then, bye.